Hello.
Yes, ma'am. Yes, ma'am.
Yeah. So, good evening, Sandeep, and good evening, everyone. So, today we are discussing the fourth live discussion, and we will be discussing week 3 of this NPTL course, Symmetry and Group Theory. And as you know, I am Shruti, I'm PMRFTA for the course. So, let's start the discussion. Sandeep, have you submitted?
Yes, ma'am. I have submitted, but a few questions got wrong. So it will be better if it will be discussed in the class, then I will get to know which question I committed mistake.
Yeah, okay. So, we are discussing assignment third. Okay, let's start. So I think assignment third was the easy one. Only maths was there.
Yes, but few answers. One was okay, but I have doubts in uh, question number three. Question number three, as I had told earlier in the
Yeah, yeah, yeah. So this one options
it
are
will,
options itself are wrong.
yes, 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 ma'am.
Huh. So this is not your fault. Options are not correct. Okay,
Yes,
let's
ma'am.
start for the first one. write the matrix representation for the product c3 square dot I. So for the combined operation we have to write the matrix. Now what is the matrix for I? Transformation matrix of I. So we can start with, I will invert everything, 1 0 0 minus 1 0 0 0 minus 1 0 0 0 minus 1. Okay, then I'll turn my video. Okay, so what will be the matrix for C3 square? This is the main thing which we need to know. Now as I told you that when we do C3, when simply C3 is written, we do clockwise rotation by 240 degree. Okay, this is the convention. So when C3 2 is written, this is clockwise rotation by 120 degree. Okay, so now what is the matrix for clockwise rotation? By any angle theta, cos theta,
With cos theta,
sin theta 0,
0.
minus sin
Minus sin,
theta,
then
or
cos theta,
yes, 0
0,
0
0, 0, 1.
1. Any angle theta and taking the rotational axis as z axis. So instead of theta we have to replace by 120 degree and not 240 degree. So this was the catch here. So when you will replace, you will get C3 square is equals to cos 120 degree sin 120 degree 0 minus sin 120 cos 120 0 0 0 1. Okay, what is the value?
Cos 120 degree is minus half.
Minus
And
half. This will be root
it
3
is root
by
3
2.
by 2.
This will be minus root 3 by 2. Okay, so this is C3 square. Now we have to multiply it with I. So I'll do it here itself. I is minus 1 0 0 0 0 minus 1. Okay, so this is d of C3 square dot d of I. D means the transformation matrix. Okay, so when you will multiply, what you will get? Minus half into minus 1 will be plus 1. Since I is diagonal, only the diagonal elements will get affected. You can do the complete multiplication and check. And then this was root 3 by 2. This is 0. This is minus root 3 by 2. And minus half and minus 1 will again become plus 1. Plus half. 1 into minus 1 is minus 1. So this should be the answer. Option number C. Okay, okay with this?
Ma'am, actually, in that multiplication, the sign should reverse.
Which one?
Because when we are multiplying, that here it should be minus root 3 by 2 after multiplication. Yes, ma'am.
This is the correct. This one is the after multiplication matrix.
Here in the first row it should be plus half is okay. Then it should be minus root 3 by 2.
Why?
Because we are multiplying with a
Okay,
we are
let's
multiplying
do.
with a unitary matrix, na? But its sign is negative. So when we are multiplying the first row with the second column, then it should give minus root 3 by 2.
Okay, let me. If I did mistake in my matrix, then let's see. Minus half into minus half. This will be minus half. Then minus half into this 0, 0. Sorry, root 3 by 2 into 0, 0, 0 into 0, 0. Okay. Then this is the first element. For second element, we have to do with this second row, second column, right? Oh, sorry, first row, second column. So this will be minus half into 0 will be 0. Then root 3 by 2 into minus 1. Yes, minus root 3 by 2. And then 0 into 0. Yeah, this will be minus root 3 by 2. Yes.
Yes.
So which option is this? Option is given, or it's this also is wrong?
Um,
Minus half root 3 by 2. This also is not given, right?
yes, ma'am. None of the option is matching. The option C will come only when we are taking C3 as a clockwise rotation. So overall C3 2 will give anti-clockwise by 120 degree. So if we are taking in
Okay.
that way, then it will give answer C. So I did in that way, I got C, but
But
if we are taking
actually, that is not right. Actually, is C3 is clockwise by 240 degrees. So C32 is clockwise by 120 degree only.
yes, ma'am. It should be like this, but in that way, no answer will be matching.
Okay. There are so many mistakes in these assignments, right? Okay.
Because here also we can see when we are multiplying with the unit matrix, but the sign of the unit actually unit matrix, if it is positive sign, then actually it does not affect the matrix. But here all the signs are negative in the case of I, so
Yes, because it
it
is
will change
I.
all the signs. Yes, ma'am.
It is not identity matrix, na. It is I matrix which changes
Yes,
like
ma'am.
x y z by
It
negative
is
x y z.
yes, ma'am. It is same like I, but all the signs are negative. So it will do the entire C32 matrix will invert its sign.
Yes. So I think they should have given the, but actual convention is this only. I'm sure about this. That if we are taking C3, we have to take 240 degree. I checked in one book also. Last time someone asked,
Yes, ma'am.
I checked
Yes,
that time in some book also. This only is written. I don't know what can I do about this.
entire question can be omitted, ma'am. This.
Yeah,
Then
but
it will
I cannot do this. I'm not the one who is setting the questions and giving the answers. My work is just to discuss the question and discuss the answers. So someone else has set the question and the answers also. So
because if the same question will be asked in the exam, then it will be problem.
yeah, okay. Like one more is wrong in this, right? This one. Okay, let's see this one. So for getting inverse, we need to find the adjoints, adjoint matrix. Like for if we take this matrix as A, so A inverse will be 1 over D and then adjoint A. And how we get adjoint?
By taking the cofactor matrix, then
Yes. So we
then
get
transpose.
adjoint by cofactor A, and then we transpose this. So let's find the cofactors. Now cofactor C11 for this matrix A will be, how we calculate cofactor? For if this is the matrix and we are calculating A11, cofactor of element A11, we have to leave the row first and the first column. So whatever element is remaining, that will be the cofactor. And sign is governed by -1 to the power the number of row which you are in and the number of column which you are in, and you have to add them. So for first row, first column, the sign will be governed by this -1 to the power 1 plus 1. And the cofactor for this will be, since we are calculating for this, we have to leave this row and we have to leave this column. So this element is remaining. So this element will come here, A minus IB. So this is A minus IB because -1 to the power 1 plus 1 is 1. Now C12, first row, second column, sign will be -1 to the power 1 plus 2, which is 3. So this will be a negative function. Then first row, so it will be, so this element we are calculating, so we have to leave this row and we have to leave this column. So this element will come minus C plus ID. Now since this is minus, it will be C minus ID. Now C21 again, -1 to the power row plus column, and we have to leave C21 is this element, so we have to leave this row and we have to leave this column. So the cofactor element will be C plus ID. So this is C plus ID. Now this is negative, so it will be minus C minus ID. C22 -1 to the power 2 plus 2. Now fourth one, this one. So we have to leave this column and this row. So we are left with A plus IB. This will be A plus IB. This is plus 1. So this will be A plus IB. Now cofactor matrix is C is equals to, what are the elements? A minus IB, A minus IB, C minus ID. Now minus C minus ID, A plus IB. Now this we need to do transpose, because adjoint is transpose. So if I'll write adjoint A, this will be transpose of this. So this will be A minus IB, C minus ID, minus C minus ID, A plus IB. So this is adjoint. Now to get the inverse, we have to divide it by the determinant. Is this correct or did I make some mistake? Is this correct? C11. Let's check once more. I think there is some -1 A minus IB. So this is A minus IB. Now this is plus C minus ID. correct, right?
Yes, ma'am. Yes.
Okay. Next, now A inverse, we have to multiply 1 by D and this matrix. C minus ID A plus IB. Okay, so it will be A minus, as we have been given in the options like this, they have kept D inside, so minus C plus ID by D, C minus ID by D, A plus IB by D. Okay, this should be the answer, this should be the inverse. But in the options, none of the answers are given in which the first element is A minus IB. All are plus, and the fourth element is also all are plus. So this is also not correct. And here minus signs are given, but it is making minus A minus IB. Okay. Did you guys solve it? Anyone solved it? Okay. So this is also debatable. Now this was the third one. Let's see, we skipped one. So the second question asks the correct statement among the following. Now first option is elements of an identity matrix form Kronecker delta. What is Kronecker delta?
Delta ij equal to 0.
When
If I is not equal to j, then delta ij is equal to 0. Otherwise, it is 1. If I equal to j, then
is equals to 1 if I equals to j. So delta ij is element of a matrix which is equal to 1 when I, and that is number of row and number of column, is same, and it will be equal to 0 if I is not equal to j. Okay, so this is shorthand notation for a matrix. Now if we take, suppose if I take 1 cross 1 matrix, then we will have only one element, delta 1 1, so in which the element will be what, 0 or 1? It will be 1 only, because here number of row and number of column is same, so element should be 1. Okay, if I take 2 cross 2 matrix, there will be 4 elements. Now this first element, this is A11 element. A11 means here I equal to j, means row and column are equal, so the answer should be 1. A2 1 2, 1 and 2, row is 1, column is 2, so I and j are not equal, so this should be 0. Similarly here A21, this should be 0, and this is A22, that is second row second column, so this should be 1. Now this is a familiar matrix, so this is an identity matrix of order 2. Okay, similarly if you will do for 3 cross 3, you will get all the diagonal elements will be 1 and the off diagonal elements will be 0. So this also is an identity matrix of order 3. So delta ij is shorthand notation to write a identity matrix. So the statement which is written here is elements of an identity matrix form Kronecker delta, which is true. See, all the elements follow this function of Kronecker delta. So this statement, first one, is correct. Now second is, a symmetric matrix is its own transpose. What is a symmetric matrix? What is the definition of a symmetric matrix?
If Aij equal to Aj, if the element of the matrix is like Aij equal to Aj, then it is called symmetric.
Now symmetric matrix by definition is, as Sandeep told, if Aij is equals to A of Ji, means what we have done here. If this is a matrix, suppose I am writing one, okay, so the elements are given by Aij. I means row, this is for row, and J is for column. Okay, so first row, first column should be equal to first column, first row. Okay, if we take diagonal elements, since diagonal elements are given by A11, A22, A33, so both are equal. If you write I or J, if you write anything first, these three will be unchanged. So let us write first the diagonal elements. 1, 2 and 5. These will be unchanged. Now let's write the off diagonal elements, which are A, this is A12, first row, second column. This should be equal to A21 because we have to flip the row and column. Now A21 is this one. This is A21 element. Are they both equal? They are equal, right? So if you flip them, so we get the same element. Now let's switch A13. We can switch this one by A31. A31 is this one, A31. Now if I swap them, if we take this here and take this here, the matrix element will remain unchanged because both are -1. Now the last pair left is this one. So this is done. This one is A. What is this element? What is this notation for this element? How do I write? Anyone?
A23.
Yes. Oops. Why did I turn on Fiji? So this is A23, second row, third column. A23. Now we have to replace this by A32, which is this, third row, second column, A32. So this is both 0. So this is a symmetric matrix. Basically what we are doing, we are transposing. Transposing means the same thing, swapping the rows by column. So swapping the rows by column. So if I swap the row, this is the row and I have to make it column. So what I will do, I will write 1, 1, -1. I have taken the first row and made it first column. Now for the second, what I will do, 1, 2, 1, 2, yes, 1, 2, 0. So I have taken the second row and made it second column. Now last one, third row, which is this one, I have to make it third column. So I will write -1 0 5. So even after swapping the rows by column or the swapping the individual elements, we are getting the same matrix. So such kind of matrix are symmetric. Both are same, right? If I swap, so this is the shorthand notation of writing transpose of a matrix. So the statement which says that a symmetric matrix is its own transpose, this is a correct statement. This is a symmetric matrix, and when you transpose this, you get the same matrix itself. Okay, so this statement is also a correct statement. Now the C option is a Hermitian matrix always has real elements. Is this correct or not? Now what is a Hermitian matrix? What is the definition? Hermitian matrix is self-adjoint. Now what do I mean by adjoint? Adjoint means transpose. Adjoint is it's like our S operation, which is a combination of C and sigma. So adjoint is also a combination of two operations, transpose and conjugate. So it is like as transpose conjugate. When you transpose a matrix and then take the conjugate of each of the elements, then it is said that you have written the adjoint of the matrix. So now what is meant by self-adjoint? So self means if I have a matrix A and then and adjoint is denoted by dagger, this symbol dagger, then if I take the adjoint of it, now this is what? A transpose star. Okay, so instead of writing two symbols, we simply write A dagger. Or you can switch it, you can first take the conjugate and then take the transpose. It will work both ways. So I have a matrix A and then I have taken the adjoint of the matrix. Then after getting the adjoint, the matrix will be equal to the starting matrix. Okay, so this is called self-adjoint. Now let us take an example. I'll write a matrix A. So let me take anything. Okay, should be plus. Okay, now I want to find the adjoint. To check whether this is Hermitian or not, I have to find the adjoint of the matrix and then I have to compare it with the starting matrix. If it is coming same, then we will say it is Hermitian. Now we have to find adjoint. To get adjoint, what we will do, we have to transpose the matrix. Okay, so let me transpose. After transposing, what will be the first row? What will be the first row? Anyone?
1, 2 plus I.
First row, this side. First row.
Yes. Just 1, 2 minus I, then 4 plus I. 5 plus 4I.
5 plus 4i. So this row, this column has become row. Now second one, now this second column will become second row. Similarly this one. Okay, so we have got the transpose of the matrix. Now if you will do, since adjoint is a combination of two operations, you have to do what? Conjugate. Okay, so all the imaginary elements will get affected by it. Now let's see, I'll write here 1 minus will become plus, minus I will become plus I will become minus I. Okay, so 2 plus I, 5 minus 4i, 2 minus I, 6, 6i, 5 plus 4i, minus 6i, 2. So this is transpose conjugate, means this is a dagger. Now aren't these two same? Okay, so we can say A is Hermitian. These two are same, so A is Hermitian matrix. Okay, now the question asked was, a Hermitian matrix always has real elements, whether this statement is correct or not. This statement is not correct because we can see that these elements are not real, these are imaginary elements. But still this matrix is Hermitian. So it is not necessary for a Hermitian matrix to have all the elements as real elements. Okay, but what is important? Which element should be real? There is a constraint on some elements that has to be real. Can you figure out from this?
Diagonal elements.
Yes. So these elements has to be real. If they are not real, suppose I'll write here 2i. So after transpose it will be 2i. Okay, but when I take its conjugate, it will become minus I. So these won't match. Hence this matrix will become non-Hermitian. So the constraint on this is that diagonal elements should be real. Okay, and what is the most important property of Hermitian matrix? Where have you heard about Hermitian matrix or Hermitian or the term Hermitian? Have you read about it somewhere? Hermitian operator, yes. So we use it in quantum. Okay, so why do we use all the matrix as Hermitian in quantum mechanics, or any idea? Yes, eigenvalues are real. Now in quantum, only the measurable entity are the eigenvalues. So if the eigenvalues are imaginary, so we cannot do any measurement. Hence, for all the operators, they are Hermitian, because they have a real eigenvalues. This is the important property of a Hermitian matrix. That's why in quantum we tend to make all the operators that we use are Hermitian operators. Okay, so this is one important property, that also its determinant are real. Determinant or eigenvalues are real. Why this is coming real? Because these eigenvalues, when you calculate eigenvalues, which elements you operate on? You mostly operate with the diagonal elements. Okay, so since diagonal elements are real, hence the eigenvalues come to be real. Okay, now there is one more property, that sum, inverse or product of Hermitian matrix is itself Hermitian. Okay, this you can check. Take two Hermitian matrix and sum them and take their product or calculate their inverse individually and check whether they are coming Hermitian or not. Okay, so the question was, a Hermitian matrix always has real elements. So is this statement correct or not? Yes, this is not correct, because this constraint is only for diagonal elements. Off diagonal elements can be complex. So this one is the wrong one. Now fourth one, adjoint of a unitary matrix is its inverse. Now what is a unitary matrix? What is a unitary matrix? Anyone? Ayush? Adjoint A is equals to A inverse. Okay. So a unitary matrix is when adjoint of a matrix is its inverse. Okay, so A dagger is equals to A inverse also, or we can write it like A dagger A will give you identity matrix. So A dagger is acting as an inverse of A. Okay, now question is, adjoint of unitary matrix is its inverse. That is correct. So A dagger, this is the definition itself of a unitary matrix, that adjoint is its inverse. Now A dagger is adjoint, which is equal to its inverse. So by definition, a unitary matrix, that statement is correct. And what if the matrix has all real elements, then what we call that matrix? A unitary matrix having all elements as real, what we call that matrix? Anyone? Yes. So it is called an orthogonal matrix. Why? See, it is called orthogonal. By definition, what is an orthogonal matrix? Orthogonal matrix means when A transpose is equal to A inverse. Okay? And we had unitary, in that A dagger is equals to A inverse. Okay? Now what I told, the A dagger is a combination of two operations, transpose and conjugate. So A transpose and then we take conjugate, it will be equal to A inverse. Now when I say that unitary, a particular kind of unitary matrix in which all the elements are real elements, so will this conjugate operation affect it? There is no I term, no imaginary term, so this will be equal to A transpose is equal to A inverse. So now this is same as the definition of an orthogonal matrix. Okay, so when all the elements become real, we, for such kind of unitary matrix, we have a special name which is called orthogonal matrix. That transpose becomes its inverse. Okay, now so the answer, the option was adjoint of a unitary matrix is its inverse. This is by definition correct one. So the correct statement should be A, B and D. Sorry, D. Okay, everyone got this correct? Ayush, Dr. Patel, did you guys submit the assignment? Okay, okay, fine. Okay, now come to third, we have already discussed. Let's come to fourth one. Okay, now a matrix is singular when its determinant is necessarily zero, non-zero, real or imaginary. This is a very basic question, 12th class question. When what is a singular matrix? So by definition, a matrix is singular when its determinant is 0. Okay, but can you tell me the cases or the special scenarios in which a determinant becomes 0? This we have studied in class 12th or 11th. What do you mean by trivial solution, Sandeep?
When all the elements are 0, 1, all the individual
Trivial
elements will become 0.
null matrix.
Null matrix.
Yes. So that is correct. That is one thing, that when a matrix is null, it is a singular matrix. So null matrix always singular. Now anything else? Now what are the criteria for a singular matrix? Is this matrix singular?
It should be invertible.
Is this matrix singular? Both?
It is not. It is not singular. It should be a square matrix.
Yes. So there is one more criteria, that determinant 0 and it should be a square matrix. Okay, and if both these things are there, then one more thing will come in. If these two things are there, then its inverse will be not defined. Okay, so the basic definition for a singular matrix we can say is a square matrix whose determinant is 0 and thus its inverse doesn't exist. Okay, so some examples of singular matrix will be a null matrix or any n cross m matrix. And one more thing should be that if any two row or column is equal, then what happens to determinant?
It is 0. 0.
Determinant becomes 0, so thus the matrix becomes singular. Okay, so you can simply by looking check whether a matrix is singular or not if they have any two row or any two column or any three row or three column, any number of rows or column same. So one more way of writing this statement will be that for a singular matrix, all the rows and columns should not be linearly independent. Okay, if they are linearly independent, then determinant will definitely exist. If it is a square matrix, then determinant will exist and hence it will be not singular. And if they are not linearly independent, then its determinant will be 0. Now when they are not linearly independent, they can be written in one more way, like any row or column is a scalar multiple. It is, I am writing the same thing, this thing which is written in purple, I am writing the same thing in simpler language, that if any row or column is a scalar multiple of any other row or column. Okay, if this happens, then also determinant is 0, because that scalar multiple you can take out of the matrix and then it will become a matrix with 2 row or 2 column equal, so the determinant will come to 0. Okay, so this was all about singular matrix. So the correct answer should be matrix determinant is necessarily 0. There is no exception to this. Now let's come to the next one. Unitary transformation of a unitary matrix always gives a matrix that is. Anyone did this? This was done in class. Okay. Ayush? Are you guys watching the lectures or simply submitting the assignments? Okay, correct. Yes, it will be unitary. So, unitary transformation of a unitary matrix gives a matrix that is unitary. This is the correct thing. Now, unitary transformation. Unitary transformation is a similarity transformation which is done by a unitary matrix on a unitary matrix. So this is a similarity transformation. Suppose I have a matrix A which is a similarity transformation of a matrix B by X. Okay, so if my B matrix, which is my starting matrix, if B is unitary and if X is unitary on through which I am doing similarity transformation, then this kind of similarity transformation is just named as unitary transformation. So it is not anything new, it is just a similarity transformation done by and done on a unitary matrix. Now the statement tells that if we use a unitary matrix to do similarity transformation on an unitary matrix, the resultant matrix, which is A in this case, this should also be unitary. We have to prove this. Okay, so let's start. Let me take, like, if we have to prove X is unitary. How do we prove that X is unitary? What is the definition of a unitary matrix? Definition is A dagger is equals to X dagger should be equal to X inverse. This we have to prove. Okay, let's take this X and we have to perform unitary transformation on this matrix, which is a unitary matrix given, and through which matrix we are doing transformation? Another unitary matrix. So given things are, U is unitary, which means U dagger is equal to U inverse, and A is also unitary, which means A dagger is equals to A inverse. These things are given and we need to prove this one. Okay, now let's start. So first we need to find X inverse, right? So let me take X inverse. If I take inverse of this, how shall I write this? Okay, let me start with here. So if I will multiply this by U, left multiplication, so I will get Ux is equals to U inverse AU. Okay, now U inverse, any matrix multiplied with its inverse gives the identity, so this will be simply Ux is equals to AU. Now can I do right multiplication with U inverse again?
Yes, ma'am. Yes, we can do.
Okay, so or we can simply do, we need to find X inverse, right? So we can do right multiplication, so left multiplication with A inverse. Now A inverse Ux, this will, because this side will become identity then, so A inverse AU, so this will be equal to U. Now next step, I will do multiplication with right or left, doesn't matter, we have to make this side as identity. This is equal to E. Okay, so since this side is equals to identity, it means all these terms are equal to inverse of X, because X inverse X will give me identity, right, always. So since X is this one, so whatever remaining elements are there, they compose X inverse. So X inverse is equals to U inverse A inverse U. Okay, and now there is a matrix property. When we write AB whole inverse, it becomes B inverse A inverse, right? So you see here we have U inverse into A inverse, so I can write this one as AU whole inverse. See, AU whole inverse into U. This side is X inverse. Now we have got X inverse, so this part, half part, is done. Now let's see, now we have to find out the dagger, means transpose conjugate. Now I will convert this into, I will again do left multiplication with AU, so that this part again becomes U only. Now this is AU X inverse is equals to AU inverse U, which is U. Now again AU X inverse u inverse is equals to u inverse is equals to E. Okay. Now x is equals to since this is x inverse, so whatever remaining is x, so that when we are multiplying it with multiplying we are getting E. So I can write it as x is equals to AU into U inverse. Okay, we got x as this. Now if I put dagger, x dagger is equals to, this was in bracket, x dagger is equals to AU dagger U inverse dagger. Now dagger is also acting like a transpose, so when you will do AU dagger it will become U dagger A dagger, and this will be U inverse dagger. Okay, now since all these elements are unitary, so U dagger is equals to U inverse, A dagger is equals to A inverse, okay, and U inverse dagger is equals to U. This we got as x dagger. Now what we had for x inverse? X inverse was this. Which is same as what we got for x dagger. So it is basically, the proof is obvious, but we just need to do left multiplication, right multiplication with u and a, so that we get this thing, that x dagger is equals to x inverse. Okay, this is the proof. So x is unitary. Okay, everyone fine with this? Okay, now of the following quantity that is not an eigenvalue of the given matrix. Now we have to find the eigenvalues of the matrix, and then we have to check whether which of these is not an eigenvalue. How do we find eigenvalue? What is the method to find? How do we start? By the way, which matrix is this? For which operator this is the matrix?
It is a rotation matrix by clockwise rotation matrix.
Yes, this is a clockwise rotation matrix for rotation axis z by any angle theta. So we have to find the eigenvalue for this. Suppose we say that this is a Cn plus matrix along z. Okay, so to get eigenvalues, what we do, we Cn plus z, this is the matrix, let's say it is A is easier to write. Now we have to first write its characteristic equation. characteristic equation is equals to A minus lambda, which denotes the eigenvalue, lambda times E determinant is equal to 0. So if you have a lambda E, what will be lambda times E? 1 0 0 0 1 0 0 0 1. If you multiply this by a lambda matrix, you will get lambda 0 0 0 lambda 0 0 0 lambda. So lambda is this. Now this you have to subtract from the given matrix. So characteristic equation will become, only diagonal elements will change because other off diagonal elements are 0. For this one, off diagonal elements are 0 and diagonal elements are lambda. So from the given A matrix we have to subtract lambda from the diagonal elements, and off diagonal elements will be unchanged. So this will be cos theta minus lambda sin theta 0 minus sin theta cos theta minus lambda 0 1 minus lambda 0 0, and then we have to find the determinant of this and then equate it to 0. Now let us find determinant. How we find determinant for a 3 cross 3 matrix? First term.
Ma'am, we can expand from the last row. Last row is having 2 0 now, so if we are expanding, then it will be simpler.
Okay, anyway.
Because already 2 terms are 0, so only one expansion.
Yes. So 1 minus lambda, and then this matrix cos minus lambda sin theta minus sin theta equal to 0. What we will get? Cos theta minus lambda whole square minus plus sin square theta equal to 0.
Expansion is not required. We can directly from the above equation, from the first step itself, we can do that. The first value will come lambda equal to 1.
Yes.
1 minus lambda equal to 0. Then
this is
the
1.
term, yes. Then the second term we can write cos theta minus lambda whole square plus sin square theta equal to 0. That term, when we are taking sin square theta on the right hand side, then it will give minus sin square theta. That term we can write as plus minus I sin theta, that after taking the square root.
Yeah, anyway you can solve. You just need to solve this. Okay. So whatever way you feel easy to find the roots of this equation. Now on equating, first value we will get 1, and then when you will solve this one, you may use the quadratic formula. You will get lambda is equal to cos theta plus minus I sin theta. Okay, so there are 3 eigenvalues which should be there because the order of matrix is 3 cross 3 and minus 1 is not there. So
answer given is plus 1, but plus 1 is the is one of the eigenvalue.
So answer given is plus 1?
Plus 1. I had tipped minus 1, but
are you sure?
Yes ma'am. Yes ma'am.
1 second. When I had checked it was minus 1. So many answers are wrong in this. This is a third week assignment, right?
Yes, ma'am. Yes, ma'am.
No, answer given is -1 only. D is given, right?
D is given, but in the that online checking now
Okay.
they have given +1 as the answer.
Acha, okay, okay. You are telling like when you will submit here.
Yes, ma'am. Yes, ma'am.
Here, okay. Oh, let me see. Oh, here, huh? Accepted answer 1. Okay. In all these things, what can we do in this? We can't do anything. Maybe you can mail directly to the NPTEL, because these things none of us are handling. The NPTEL team itself handles. So you can either mail to them.
Ma'am, earlier also in earlier courses also they had changed because we can make some mail in the discussion forum
Yeah,
and from
then you can write here, na, in the discussion forum.
yes, ma'am, there we can write.
Huh. Either you can write here or you can mail to this. You can write here or you can mail to NPTEL.
Because NPTL will not change. Because NPTL will not change. Only the professor has to change. The professor and their TAT.
No, no, no. The professor won't change. Professor is not handling any of this.
Then
The
there
NPTEL team is handling. So, how the process is, the professor teaches the course, his duty overs there, then the TA makes the assignment and the solution, and then NPTEL team, like weekly, they put the questions and then check the answer. And
yes,
there are two TAs, one takes the live discussion and one who makes the questions and answers. So like this it runs. So if you have doubt on the question, like answers are wrong, then you can either put in the discussion forum so that the NPTEL team sees it, and either you can directly mail to them, because this will hamper your grade, right?
but if any question answer is wrong, if the answer itself is
Yeah,
wrong,
better to write
whatever.
in the discussion forum first. If it is
Okay,
not being correct, then you try mailing them.
okay.
Okay. So this one, A and B are this one I did in the last session, na? This is the same question. Determinant will be A square minus B square, so it will be plus. And then for adjoint, I had given the trick that change the sign of diagonal elements. So this will become B, this will become minus B, and interchange the diagonal elements. So the inverse will be 1 upon A square plus B square, AB minus BA. So this will be the inverse. This is the same question. Uh, it was given in assignment 2. Now this one question is adjoint of the matrix e to the power ikx omega 8 and 5. What is omega?
Omega is just number we are taking here as a.
No, what does it mean? It is a cube root of unity, cube root of 1. Okay, you can check what numbers are associated. Is it real or imaginary?
It is imaginary.
Yes. What do you know the value? It is something 1 by 2 plus minus root 3 by 2 I.
Yes, ma'am. It
Okay,
is minus 1 plus I root 3 by
2.
2.
Okay, so adjoint of this one. Now, adjoint means cofactor and then transpose of the cofactor matrix. So, cofactor matrix will be, let's say, C11 term. So, it will be 5 because we have to leave this row and this column. 5 C12 term, leave this row and this column, it will be minus 8 because it is 1 and 2. So for getting cofactors we have to take care of the sign. If the sum of row and column is odd, you have to put a negative sign before the element. C21 it will be minus omega, and C22 it will be e to the power ikx. So the cofactor matrix is 8 minus 5 minus omega e to the power ikx. Okay, so we have to take transpose of this to get the adjoint. Now adjoint will be 5 minus 8 minus omega e to the power ikx. This option is also not there.
And it will not come like this because for complex number we have to take the complex conjugate also. And even after taking the complex conjugate, the answer was not coming. So none of the option is matching
No, 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 no.
because we have to take the complex conjugate.
Okay, if I
Adjoint means
adjoint transpose, okay, this is complex. If I'll take, now we have to take conjugate, then let me write here, it will be 5. Omega is equals to plus minus e. So if it is minus, plus minus, and if it is minus, then also it will be minus plus omega, like that. No, no, no. Omega is equals to, omega square is minus e, right? Omega is plus e. So let me remove this. Omega is equals to 1. It is plus I root 3 by 2. Is this fine? Is it plus or minus? Can anyone confirm?
uh, omega omega is minus 1 plus minus
Minus
1.
1 plus. So
Yes,
if you will take minus omega, it will be 1 minus I root 3 by 2.
yes, ma'am.
Okay.
It will become omega square.
And
We are
then
saying
you
it.
will take conjugate. So it will become omega square. 1, it won't become omega square actually. Omega square will have minus here also in front of 1. So it becomes this. Now this is neither omega nor omega square. So if I take, okay, if I take minus sign before, it will become minus of omega square, and then minus 8 e to the power minus ikx. It will become this. Do you agree with me?
Ma'am, we do not have to take cofactor matrix. It is just adjoint is just the conjugate transpose, no? Adjoint is just the conjugate transpose.
Yes, if I do it, actually, I had already taken the cofactor matrix.
Cofactor matrix is not required because just we have to take the
So either you do the conjugate transpose or you do the cofactor and then transpose. Okay. So let me do simply the transpose and then take the conjugate. But both ways answer should come in any of these, right? The matrix is e to the power ikx omega 8 5. Okay, I will do transpose and conjugate simply. Let's see whether by any of this it matches. So this is transpose. Now transpose and then let's see conjugate. Now if you want to write omega as -1 minus I root 3 by 2, so omega star is equals to -1 plus I root 3 by 2, which is basically omega square. Okay, and since it has a property, no, it is not needed, so we can write here omega square and this will be 5, but none of the options have given omega square.
yes, ma'am. None of the option is given omega square.
Okay, so if they are not taking omega as the cube root of unity, if it is simply omega, then is any of the option coming like that?
Ma'am, if you are taking omega as a real number now,
So
then
then it should come, right?
then option C will come.
Then
But option
option C
C,
will come.
I had marked option C, but they have not given it as an answer.
What
They have
is the answer given?
answer they are whatever official they have checked now, for which they have given marks. That answer C they have given wrong.
They
So
have
that
given B here.
yes, they have given B here.
So this is also not correct.
Not C, but they have not given that answer.
But in both ways, either by taking cofactor and transposing or by transpose conjugate, B is not coming. Or even if we take omega as real number,
If we are taking omega as real number, then option C will come.
then option C will come. B will not come, right? They have given
Yes.
B.
Yes, ma'am.
B is so this question is also wrong. Oh God, so many wrong answers. Okay, let's see what we can do with this. So how many answers are wrong in this one? One. Okay, the first one by definition, this is wrong. They should have mentioned which axis we have to do the rotation. 1, 2 and
Question number 3 is wrong.
3.
Question number 3.
3 I have counted, so it's like 4 questions. 3 questions are wrong. Now let's see this one, if this is correct or not. Now eigenvalues. So I will directly write as 2 minus lambda 4 minus I 4 plus I minus 14 minus lambda. We have to calculate determinant equals to 0. Now 2 minus sorry, okay, minus 4 square minus I square equal to 0. So when you will solve this, what you will get? I have solved this and I got this equation, this quadratic equation. Okay, you can try, this is simple maths. And after solving, I got lambda equals to 3 and minus 15. So these are the eigenvalues. And the question asks the eigenvalues. So the answer should be A and B. Is this correct?
Yes, ma'am, this is correct.
Okay. So this is a second order linear equation, second order equation. So we have two eigenvalues. If the matrix order is 3, we will get 3 eigenvalues. Number of eigenvalues depends upon the order of the matrix. Okay, so this is the last question. Any doubt? Apart from the wrong answers given in the solution?
No, ma'am. But there are 4 answers are wrong, na?
Yeah.
At least 3 questions wrong and one was wrongly evaluated. So total
Yes.
4 questions.
You can right now you can write in the discussion forum, Sandeep.
Yes, ma'am.
Yeah, you can just write that these questions are wrong, and you can, if there is an option, you can provide the correct solution as well. Let me see.
Actually, they are not replying often. Often, this chemistry section I have seen, they are not replying. They they generally do not reply in chemistry only. But in other courses, in other NPTEL courses, they reply often. But in chemistry,
Few people have asked some questions. Video missing. They are replying, Sandeep. See, they have replied to someone.
only one reply may have come, but in other
Okay,
cases
but
they are not.
there is no harm in trying. You can just put your doubt that these questions are wrong. Please reevaluate. Then they can connect with the TAs and we can provide them the correct solution. Okay. Unless there is a like query from the students, we can't do anything. Okay. One.
In the previous week also, the first
2,
question was wrong. First question.
3. Yeah, whatever, you can simply like make a list and then put them in the discussion forum. Then they may contact us, or the TA who is making the questions, they can contact them and then the answers can be corrected.
Okay, ma'am.
Yeah. Okay. Okay, so there are 3 more questions which I have kept. These are not given in assignment. So this is the same as the one we discussed. A matrix is Hermitian when it is. Can anyone else reply? So a matrix is Hermitian when it is, by definition, a Hermitian matrix, how do we write?
Adjoint of itself.
A dagger is equals to A inverse. So adjoint is inverse. So sorry, adjoint is not inverse. It is adjoint of itself. So this is self adjoint. So this is third option. A non-trivial solution of a matrix eigenvalue equation determinant A minus lambda E is. How we get non-trivial solution?
By equating it to 0. By equating
Yes.
the determinant equal to
Yes.
0.
So by equating the determinant to 0, we get the non-trivial solutions. How to get the trivial solutions then?
All the elements will be 0. All the individual.
Yes. So by taking all the individual elements as 0, that is a trivial solution. If everything is 0, then it is a null matrix. There is no question of asking determinant and eigenvalue for that. Now this one, a multiplication table of a group is provided. For this group, the set of elements that belong to the same class among the following sets are. Can you do this as a homework? Or right now if you want? What is the criteria for an element, for two elements to belong in the same class? That they should
This should be connected by similarity transform.
Yes. They should be symmetry transformable if we take any other element that may or may not be from the same class. Okay. So suppose I will take first I have to find the element which is in the same class with this element A. Okay. So let me write A here, and then I will check this with respect to every other element. Okay. Suppose first if I am checking with this E, now for similarity transformation I left multiply with inverse and right multiply with the element. Now this will give me A itself, right? Because A into E is A, and then E inverse is E, because E dot E is E. So E is itself inverse. So this will give me A. Okay, now let me write it A again, but this time I want to do the similarity transformation with respect to B to check whether B and A are in the same class. So this gives that E is in class of A. Now let me check with B inverse B. Now A dot B, what will be the A dot B? This is A, this is B.
F.
It will be F. B, what is B inverse? No, actually order of multiplication matters. Now what is B inverse? We should not write F first. Order of multiplication matters. What is B inverse?
B itself.
So B inverse is B itself because we are getting E under the B column. So it is B A B. Now B dot A, what is B dot A? B dot A is D. This is D, and then again B. Now D dot B, this is C. So this is giving C. Okay. So A and C they are in the same class, because C can be formed by the symmetry transformation of A. Now let's check another element. Now I will do similarity transformation with respect to C. So I have to left multiply with C inverse and right multiply with C. Now C inverse is where I am getting E. So C
C
inverse is C itself. CAC. Now CA is C times A.
F.
F. So this is F and then C. F times C. This is B. So B is also in the same class as A. Okay. So A, B and C are in same class. Now let's check D. Okay. With respect to A. So I will keep A here and D. D inverse D. Now D inverse will be, D inverse is F. Okay, it is coming in F column. D inverse is F, then A and then D. Now F dot A. F
B.
A.
It is B. B.
F A
D.
is C and then D. And then C dot D. It is C and D. It is B. So it is giving B. So again we are getting B. So B, I told you, is in the same class. So
Ma'am, from the last we are doing now, like from D inverse AD, we did FAD. Then we are doing starting
FA.
from DA now. DA. In the last D and A are there. So first we are starting.
FA. I did F and A. F is here, A is here. So F dot A is C.
Okay.
You got it? So even if I take an element which is outside the class and operate similarity transformation, it is giving me an element which is inside the class only. Okay. So A, B and C are a class. So similarly you can check with other elements. You can check with D, because since A, B, C are in the same class, so whatever you operate, you will get A, B, C only. D and F, if you check. Now let's check D. I'll write here D, and let's check this with C. Let's check. So I'll operate C inverse and C. Okay. Now what is C inverse? C inverse is E, then DC. Now E and D will be D and then C. Now D dot C, D dot C is giving me A. No, this cannot be.
Then C inverse is C itself. Huh?
C inverse, oh sorry, C. I had to write C. Yeah. This is C, D and C. Now C dot D is B and then C. B dot C is F. So we are getting F, another element. So when you will check like this, you will find that D and F are in the same class. Okay. So ABC is a class, 3 elements, so order 3. D and F is a class, 2 elements, so order 2. So the answer should be A and B. A and B are in a class, B and C are in a class, C and D are not in a class, D and E, E is in every class. So you can write D and E also. Okay? Is this okay? Yeah. So that's all for today. Today's questions were easy only, but the answers given are wrong, but that doesn't matter. That should not matter much. Whatever you learn and you are able to do, that only matters. So this question wrong answer thing you can post in the discussion forum, Sandeep, and let's see what happens next.
Yes, ma'am. Yes, ma'am. Okay.
Yeah. Then I'll close the discussion today.
Okay, ma'am. Thanks, ma'am. Thanks.
Yeah.